If you were to remove every star, every planet, and every grain of cosmic dust from the sky, the universe would not be empty. It would be crowded. We have spent decades looking at the light, assuming the darkness was merely a backdrop, a void waiting to be filled. We were wrong. The darkness is the structure. It is the scaffolding. 85% of the matter in the cosmos is invisible, a ghost mass we call dark matter. For 40 years, the hunt for this missing mass focused on the microscopic, on subatomic particles so weak they pass through lead walls like moonlight through a window. But after 40 years of silence from our deepest laboratories, the search has pivoted. We are no longer looking for a cloud of particles. We are looking for a swarm of shadows. We are looking for primordial black holes. These are not the black holes you were taught about in school. They are not the collapsed remains of dead stars. They are older than the stars themselves. They are artifacts of the first billionth of a second after the Big Bang, frozen ripples of gravity that have been wandering the vacuum for 13.8 billion years. They range in size from a single atom to the width of a mountain, and they are likely everywhere. Right now, one could be drifting through the room where you sit. Another could be hollowing out the core of a distant moon. They are the universe's original sin, a legacy of a time when the entire cosmos was so dense that gravity itself began to fracture. To understand the primordial black hole, you must first discard the image of the stellar giant. When a star 20 times the mass of our Sun dies, it collapses under its own weight, forging a black hole that is miles across. This is the standard model. But in the first trillionth of a second of existence, the universe didn't need stars to make black holes. The universe itself was the engine. Space was a hyper-compressed soup of radiation and plasma, a chaotic broth of energy where the density was so extreme that even a slight ripple, a quantum shiver, could trigger a total gravitational collapse. If a single pocket of that primordial soup was just 60% denser than the space around it, the expansion of the universe couldn't pull it apart. Gravity would win. The pocket would pinch off from reality, forming a singularity. Because these formed before the first atoms, they are not bound by the laws of stellar evolution. They can be any mass. They can be as light as a snowflake or as heavy as a galaxy. And because they are black holes, they emit no light. They are the perfect candidate for the missing mass of the universe. The implications of this are not merely academic. If dark matter is comprised of these ancient singularities, then the solar system is not the peaceful neighborhood we imagine. It is a shooting gallery. Theoretical models suggest that if primordial black holes make up the bulk of dark matter, then millions of them must be drifting through our galaxy. Statistically, one of these objects, perhaps the mass of a large asteroid but compressed into the size of a single hydrogen atom, should pass through the inner solar system every few decades. Consider the physics of such an encounter. A primordial black hole of this mass would not act like a vacuum cleaner. It wouldn't suck in the Earth. Its gravitational footprint is too small for that. Instead, it would act like a cosmic needle. If an asteroid-mass primordial black hole were to strike the Earth, it wouldn't leave a crater. It would move at 400 kilometers per second, far faster than any meteor. It would punch a hole through the atmosphere, through the crust, through the mantle, and through the core, exiting the other side of the planet in a matter of minutes. It would leave a microscopic entry wound and a supersonic shockwave of heat and radiation, but the planet would remain largely intact. Some researchers believe we have already seen this happen. In 1908, a massive explosion leveled 800 square miles of Siberian forest near the Tunguska River. While it is often dismissed as a meteor, The mathematical signature of a black hole transit matches the seismic records of 1908 with haunting precision. No fragments were ever found. No crater was ever located. In the 1970s, physicists proposed that the Tunguska event wasn't an impact, but an entry wound. If a primordial black hole punched through the Earth, there should be a corresponding exit wound on the other side of the planet, likely in the North Atlantic. It would have been a silent, invisible bullet fired from the dawn of time. But the threat isn't just planetary, it is biological. Physicists have calculated the odds of a microscopic primordial black hole passing through a human body. It is a scenario of localized, absolute violence. Because the black hole is so small and moving so fast, you wouldn't feel a pull. You would feel a puncture. As it tunneled through you, the intense gravitational gradient would disrupt the very matter in its path, leaving a microscopic trail of high-energy radiation. It would be like being hit by a bullet that is simultaneously 1,000 degrees and weighs 1 billion tons. You wouldn't see it coming. You wouldn't hear it. You would simply be left with a subatomic wake of structural damage through your vitals. The odds are low, perhaps once in a human lifetime across the entire population, but in a universe filled with these ghosts, it is a mathematical certainty that it has happened to someone, somewhere, at some point in history. The danger of these objects is not limited to their movement. It is found in their very existence. If a primordial black hole were to be captured by the gravity of a larger body, it wouldn't just sit there. It would sink. Because a black hole is denser than any known material, it would drift toward the center of a planet or a star like a lead weight through water. Once at the core, it would begin to feed. This is the parasitic core hypothesis. A primordial black hole the size of a grain of sand could be sitting at the center of the moon right now. It would slowly, atom by atom, consume the lunar interior. For billions of years, the moon would look normal on the outside, but its core would be hollowing out, replaced by a growing singularity. Eventually, the structural integrity of the sphere would fail, and the moon would simply collapse into itself, vanishing into a point of infinite density. This may not be limited to moons. Our own sun could be hosting a parasite. Some models of stellar evolution struggle to explain why certain stars seem to burn out faster than they should. If a small primordial black hole is lodged in the heart of a star, it would act as a secondary engine, consuming the hydrogen from the inside out. It would be a cancer of the cosmos, a dark heart beating inside a shell of light. This isn't just a dark fantasy. The evidence is mounting, and it is coming from our most advanced instruments. The James Webb Space Telescope was designed to see the first stars, but it has found something it wasn't supposed to find. In the deepest reaches of the early universe, James Webb has spotted little red dots, galaxies that are far too small, far too bright, and far too mature for their age. According to our current understanding of gravity, these galaxies shouldn't have had enough time to form. They need a seed, something incredibly heavy to pull the gas together in the first few 100 million years. Standard black holes, born from stars, are too small and grow too slowly to do the job. But a primordial black hole? A singularity born in the Big Bang with the mass of 100,000 suns? That is the perfect seed. James Webb may not be looking at the first stars. It may be looking at the first black holes, the invisible architects that built the universe we see today. While James Webb looks at the light, other instruments are listening to the rhythm of the vacuum. In 2023, the Nanograv collaboration released the results of 15 years of observation. They weren't looking at stars, but at pulsars, cosmic metronomes that beep with perfect regularity. They found that the timing of these beeps is being slightly, rhythmically distorted. The entire universe is humming. This stochastic gravitational wave background is a low-frequency vibration that fills all of space. While many attribute this to the collision of supermassive black holes, a growing faction of physicists believes this hum is the echo of the primordial era. It is the sound of millions of small black holes being forged in the first microsecond of time. The hum is the signature of the swarm. Even closer to home, the LIGO observatory has been detecting the ripples from black hole mergers. Most of these involve objects 30 or 40 times the mass of the Sun. But occasionally, LIGO sees something impossible. It sees mergers involving objects in the mass gap, too heavy to be a neutron star, but too light to be a stellar black hole. These are the orphans of astrophysics. They shouldn't exist according to the rules of how stars die. But they are exactly what we would expect if the universe is littered with primordial black holes. They are the survivors of the dawn of time, finally crashing into each other after 13 billion years of solitude. Perhaps the most compelling evidence for these invisible neighbors lies in the outer reaches of our own solar system. For years, astronomers have noticed a strange tilt in the orbits of the objects beyond Neptune. Something massive is out there, tugging on the icy rocks of the Kuiper Belt. We call it Planet 9. We have searched for it with every telescope we have, looking for a faint glimmer of reflected sunlight from a cold, distant world. We have found nothing. In 2019, a radical paper proposed a simple explanation for why we can't find Planet 9. It isn't a planet. It is a primordial black hole. If you take the mass of 5 to 10 Earths and compress it into a black hole, it would be the size of a grapefruit. It would be pitch black, invisible against the void of deep space. It would have the same gravitational pull as a planet, but none of the visibility. It would explain the orbital anomalies perfectly. It would mean that at the edge of our solar system, just past the reach of our probes, sits a remnant of the Big Bang itself, a grapefruit-sized tear in reality that has been orbiting our sun since the beginning of time. But even a black hole is not eternal. This was the final realization of Stephen Hawking. Through a process now known as Hawking radiation, black holes are not perfectly black. They leak. Due to quantum effects at the event horizon, black holes slowly emit particles, losing mass over eons. The smaller the black hole, the faster it leaks. A supermassive black hole at the center of a galaxy will take trillions upon trillions of years to evaporate. But a primordial black hole, born with the mass of a small mountain, would be reaching the end of its life right about now. As a black hole evaporates, it gets hotter. In its final seconds, the process accelerates into a runaway reaction. The singularity begins to glow, then shine, then scream in high-energy gamma rays. The final moment of a primordial black hole is not a whimper, but a flash, a backwards burst that releases as much energy as 1,000,000 nuclear bombs in a fraction of a second. This is the final flash. If the universe is full of these objects, the sky should be flickering with these terminal explosions. We have seen flashes in the gamma-ray sky, short, violent bursts that we struggle to explain. Some of them may be the death cries of the very first objects ever created. However, there is a contrarian angle that is even more unsettling. Some recent theoretical models suggest that our understanding of Hawking radiation is incomplete. They propose that as a black hole reaches the Planck scale, the smallest possible size in physics, the evaporation stops. Instead of exploding, the black hole leaves behind a relic, a stable, hyperdense nugget of pure gravity that can never disappear. If this is true, the universe is not just a graveyard of evaporating ghosts. It is a storehouse. Every black hole that has ever formed in the history of the cosmos is still here, invisible and immortal, drifting through the vacuum like a diamond made of darkness. We are forced to confront a new reality. We have spent our history as a species looking at the 5% of the universe that glows, believing it to be the whole story. We thought we were the protagonists of a grand celestial drama, but the data from James Webb, from LIGO, and from the anomalies in our own solar system suggest a different narrative. We are not the protagonists. We are the leftovers. We are the thin film of dust that settled on a universe built of singularities. The primordial black holes are the true citizens of the cosmos. They were here before the first atom. They will be here long after the last star has gone cold. They are the seeds of the galaxies, the parasites in the hearts of the suns, and the invisible bullets passing through our world. We live in a swarm of shadows, a silent, swirling ocean of black holes that we are only just beginning to perceive. The darkness isn't empty. It is heavy. It is ancient. And it is watching us from the center of every world we know. When you look up at the night sky, you see the stars, but the stars are only the foam on the surface of a deep, dark sea. Below them, in the gaps between the light, the primordial ghosts are moving. They are the ultimate survivors, the first and last inhabitants of a universe that was never meant for us. They are the primordial black holes, the frozen echoes of the beginning, waiting for the end. And as we continue to refine our instruments, as we listen to the hum of space and look for the grapefruit-sized tears in the dark, we may find that the most terrifying thing about the universe isn't how much of it we can't see, but how much of it has been right here with us all along, hidden in plain sight, waiting for its turn to feed. The hunt is no longer about finding what is missing. It is about realizing what has already been found. From the microscopic gunshot through a human cell to the silent gravity of Planet 9, the evidence is overwhelming. We are surrounded. The universe is a graveyard of singularities, and we are simply the light that hasn't been swallowed yet. The slope of our understanding is rising, and with every new discovery, the darkness grows heavier. The ghosts are no longer a theory. They are a presence. And in the cold, silent reaches of the cosmos, the swarm is still growing.